We're live. We're streaming. We're good to go. Okay. Are there any questions before I get started from the homework from 7.1 or 7.3? Remember, on Monday's lecture we did 7.1 and then 7.3. They really go together. 7.2 that we're going to do today is kind of a separate section. Any questions? Awesome. Okay, I'm going to keep rocking and rolling. Today we're doing 7.2. It's not a long section for what I want you to do. So we might wind up moving over to 7.4. Maybe. It's not that long. So really 7.2 talks about the relationship between a radical and an exponent. So I'm going to go over the definition. This is on page like 519 if you're following along. Look, if you have anything raised to the 1 over n, that's the same as the nth root of a. And I know I mentioned that yesterday, but today we're going to kind of cement it more and talk about it and go back and forth between both of them. Okay, so it's really a little bit more of a review on exponents than anything else. So if we had like something basic, I think we kind of talked about this yesterday, but if we had like 9 to the 1/2, if I wanted to write it as a radical, I should say, this would just be the square root of 9, which we know is 3, right? So I'm going to make kind of a chart here, and we're going to go back and forth between these. So this is going to be considered exponential. So an exponential term and a radical term. So let's say we'll do a few of them, just to go back and forth so we get kind of comfortable with how they work. So if we had something like, let's say, x to the 1/4, and all I wanted to do is write it as a radical. Well, just like up here. Now remember, the denominator of the denominator of the exponent is going to be the root of that radical, okay? The denominator of that exponent is the root of that radical. So it's just the 4th root of x. Be careful, because if we have like coefficients, let's say we had something like 4y to the 1/3. That 1/3 is only going to the 4, right? So really the 4 is raised to the 1st power. It's not raised to the 1/3 power. So if we're going to write this in radical form, the 4 stays outside, and then the 1/3, or so the cube root of y, it follows the 4. So the y, the only thing underneath the radical for this one is y. Now, if we wanted to put the entire thing underneath the radical, we would need parentheses. So if we looked at, let's say, your book does one here, 81 x to the 8th raised to the 1/4. So 81 x to the 8th raised to the 1/4. Now, this entire term, 81 x to the 8th, now is going to be under this 4th root because of the parentheses. Okay? Completely because of the parentheses. So no parentheses here. It only goes to whatever it's attached to. If we've got parentheses, in a way, it's attached to both of them. Okay? And we can simplify this one. The 4th root of 81, look, if you go back to yesterday's lecture, I feel like this popped up like 3 or 4 times. The 4th root of 81 is just 3. And then remember, if it's the 4th root of x to the 8th, how many times is 4 going to 8? It goes in twice, right? So this winds up being 3x squared once we simplify it. Okay? Questions about that? It's not a big deal. It's just going back and forth. We're going to add one more rule to this. Is, well, what if the exponent has a number in the numerator and denominator? So if we had like a to the m over n, this is what it looks like in your book. Now you can put that m inside the radical or outside the radical. And what I'm saying is you could say it's the nth root, still nth root, because that's what's in the denominator, of a to the m, or you can do the nth root of a then raised to the m. Okay? It's kind of weird that way. And it's not that one's like more correct or not correct. And I'll tell you, if you're dealing with numbers, just numbers, not variables, it's usually a little easier to do this one because you make the number smaller and then it gets bigger. So You're not dealing with like bigger than smaller. And I'll give you an example of that, or the book does one. Let's say 8 to the 2/3. If I wanted to find out what 8 to the 2/3 is, I'm going to write it this way because the very first thing we're going to do is find the cube root of 8 and then square it. The other way, we'd square the 8 and then find the cube root. Not a big deal with 8. It's not the biggest of numbers. But if we had a bigger number in that exponent, it would cause just a big number floating around there. And so parentheses tells us we need to do this first. So the cube root of 8 is 2, right? 2 times 2 times 2 is 8. So 2 squared is just 4. Okay? So first, just putting, so let's do one where we just put one of these in a radical form. And it doesn't matter. You can choose either one. If all I'm going to do is ask you to put in radical form, either one of these will be correct. So if we had something like, let's say 5x to the 7/9, just something goofy. 5x to the 7/9. Now again, the 7/9 isn't on the 5, so it's going to be considered a coefficient in front of the radical. So I'm going to put that 5 there first. The 9 is the root. Now I'm going to put this one, I'm just going to put it underneath because it doesn't matter. It's just an x. So it would look like that. Now, if I wanted to, I could say that this is the same thing, okay? Both of those would be the same. See, it kind of looks prettier this way, because there's no parentheses going on whenever you're just writing exponents out this way, but either way is fine. And notice we can't simplify it because 9 doesn't go into 7, so it can't get any smaller, okay? I'm just going to steal one from the book now. Okay, this is number, I'm just doing some examples on page 520. Let's say we've got -27 to the 2/3. Well, we already did 2/3 up there. That's fine though. -27 to the 2/3. So again, the whole thing's being raised to the 2/3. So I've got to write this whole thing underneath the radical. Now it's a cube root, so it's fine, right? We talked about that. If this was the square root, we'd have a non-real number. We'd be done. Okay, so we've got to get the cube root of 27. And then we have to square it. So, or -27, I should say. So the cube root of -27, now the negative stays with cube roots, okay? And the cube root of 27 is just 3. It's 3 times 3 times 3. If you want to do the factor tree, 9 times 3, 3 times 3, right? So we've got 3 3s. We're finding a cube root. So this winds up being -3 squared, okay? And then we know when we square it, it does turn positive. -3 times -3 is a positive 9. Okay, I'm going to park it here for like 10 seconds and ask you guys if you have any questions to chime in. And it's not that it gets harder. We're going to introduce more of the exponent rules with this moving forward. Okay, and it's not that it gets harder. In the end, whatever is the denominator turns out to be the root. Okay. And then, the exponent can come in or it can go out. And with simplifying numbers, it's not as big of a deal because in the end, you're going to work it out anyway. Okay. So let's look at 2 if it'll bleed. Okay. Let's look at one, and I'll tell you, I like putting this one on the test. So you might see this one again on the test, or one just like it. Let's do 25. I want you to try it. 25 to the -3/2. Okay, I'm going to do the number 1. Number 2, let's say 1/9 to the, hold on, let's say 5/2. You got to incorporate rules, remember, from the exponent section. And then number 3, let's do -16 to the let's say 7/4. Oh, that's a weird one. Try those three, and it's okay if you get all three of them wrong because they're kind of tricky in their own little way. And I'm going to go over each one. So try those. Okay, I'm going to start the first one. If you're still working, that's fine. I don't expect you to be done here. But okay, this is the one that when I put it on a test, I'm going to see the most missed answers. Period. Hands down. Hands down. Because we have to remember the negative exponent means we put it in the denominator first. Okay? Remember, if we have anything raised to a negative power, it means we put it in the denominator. And then we continue on with simplifying this thing. So it's going to be the square root of 25 raised to the third power. Okay? Right? So we wind up with 1 over 5 cubed. 5 cubed is 125. So 1 over 125. Okay? So negative in the exponent means it goes down, which if you remember from 1.6 and 1.7, that was one of those basic rules, right? It said if you have anything raised to the negative power, it's just 1 over a to the n, right? You just move it to the denominator. That's the rule we used to go from here to there. And then we're just completing with what we've learned today, but only in the denominator. 25 to the 3 halves. Oh, that's the square root. 25 cubed. Square root 25 is 5. We know that. 5 cubed is 125. So it just moved along as we went. Okay? Questions about that one? Okay. Now, the 5 halves, I'm going to raise to the top and bottom. Now, what's nice about 1 is it doesn't change anything. Okay, so 1 raised to anything is just 1. Okay, so that's going to stay put. And then I'm going to finish this like I did up here. So I get the square root of 9 raised to the 5th power. This is good more. Square root of 9 I know is 3. 3 to the 5th, I have no idea. I know 3 to the 4th because it popped up in like 4 examples from the last lecture. But let's say do 3 to the 5th. 3 times 3 times 3 times 3 times 3. 243. So 1 over 243. Okay? Not too crazy. Now, this last one's tricky for a different reason, and it's the fact that when we raise this to a 7/4, the negative is not actually being raised. And that's why I wanted to trick you on this one, because it's a little lower. It's because our brains want to raise the 7/4 to the -16, but in actuality, it's -1 times 16 to the 7/4, right? Remember, if there's a negative out front, it's really just a coefficient of -1. And we know with order of operations, please excuse my dear Aunt Sally, we would do the exponent before we would do the multiplication. Okay, that's where it's coming from. Now, if this was a parentheses, that would be different. I'll do that one next. But let's follow along here and see what we've got. So -1 times. Now, I'm going to write this as a radical. So the 4th root of 16 raised to the 7th power. Well, the 4th root of 16, if you want to break it down, I believe it's 2. Yeah. Right. We've got 4 2's going on, trying to get a 4th root. So that would be 2 raised to the 7th power. -1 times that. 2 to the 7th power, I believe, is like 128. Hold on. Let me check. I think I can do it sideways. Clear 2 raised to the 7th power. 128. I was right. Okay. So -128, because it's -1 times that. So -128. Ooh, man, that's great. Okay. That one took a little long. I probably wrote more steps than I had to, though. Like from here, you could have gone directly to this step, right? And then just solved it out. Or really simplify it. We're not solving anything. We're just simplifying. Okay. Questions about these three? Actually, a little higher for what we're doing here. Any questions about these 3 examples? I like these 3 examples. You might see these 3 examples again. That's what I'm trying to say. Okay. So are there any questions before I just keep rocking and rolling? Okay. Flip it over. You can kind of see the stuff in the back, but that's not too bad. Let's do that one, that last one. So ABCD. But all I'm going to do is make a parentheses here. Was it to the 7/4? Okay, so if we made the parentheses, then we would have to put the entire number underneath the radical. So we'd have the 4th root of -16 raised to the 7th. Now look, we can't have an even root and a negative radicand. Remember we talked about this yesterday? So for now, we're going to say this is non-real. And if you did the homework, it popped up, at least in one question, I know it popped up as a solution, is that it was just a non-real number. It's a non-real number, and we're going to get to that when we get to 7.7, which is really next week. It's on the next test, okay? So for now, and the reason it's a non-real number, even root, negative radicand, right? Even root, negative radicand. Can't deal with it. Okay. Questions, comments, concerns? Great. Now we're going to keep on going. So on page 521, objective D, we're really switching now to a review of exponents. And there's a whole list of the exponent rules that we've already gone over 2 or 3 weeks ago. I'm not going to go over that. So what we're going to do though is we're going to do fractional exponents and kind of combine some of these rules so you have a review of them. And let me see if, okay, here we go. I'm going to steal some kind of from the book. And it says, use the properties of exponents to simplify. So all we're wanting to do is simplify. I don't want you to put them in radical notation, just simplify, okay? And I'm going to give you a few. You should know these already, so I'm going to give you a little bit of time to do them. It's just dealing with fractions. So we got x to the 1/3 times x to the 1/4, okay? Then we've got, let's say, 7 to the 1/3 divided by 7 to the 4/3. And then lastly, we have, let's say, x to the 3/8 raised to the -4. Okay, I want you to try those. Now look, leave them in exponential term. Don't worry about putting them in radical, but I want you to simplify each one. Now that's a 4/3 right there. I know it's kind of hard to see on the screen, but it's a 4/3. My markers are getting kind of flatter, not as crisp.
Mr. Shirley,
I'm listening.
I'm on number C. Is that 3/8? Because I can't read it.
Yes, ma'am. Yes, ma'am.
Okay.
3/8.
Okay.
I'm sorry. My markers are getting kind of fatter because we're using them, and I'll try to write a little bigger.
I just wanted to make sure I wrote it right.
Yeah, no problem. Keep working. Again, I'm going to start on this one. Now I know when you multiply, that means you're going to add these, right? Oh crap! They don't have a common denominator. Your calculator could do fractions if you wanted to, but if we wanted to add 1/3 and 1/4, you got to get common denominators, right? Well, this would be 12. So you'd multiply by 4 on top and bottom, by 3 on top and bottom. So you'd have 4/12 plus 3/12, which equals 7/12. So we wind up with x raised to the 7/12. Okay. And if it's like, if you're saying, oh my God, I don't know how to subtract fractions, that's a whole different version of math. That's like the first part of this. So if you need to get on the Google and YouTube, let me know. I'll find some really good videos on how to do it that are actually kind of fun. Oh, I know it sounds horrible. Oh God, I actually said that. It sounds fun. But they make it more interesting where your brain doesn't necessarily think of it as just some horrible adding and subtracting, rote memory kind of thing. Okay, so subtracting, this will be easier because we have common denominators. So we wind up with 1/3 minus 4/3, right? So 1/3 minus 4/3, well, common denominator for subtraction, that's great. 1 minus 4 is -3. So we wind up with -1. So really, this turns into 7 raised to the -1. Now remember, in that exponent section, we can't end with a negative, so we have to make that positive. So this would be 1 over 7 to the first power. Now you don't have to write that first power, but I'm going to leave it in my answer. Okay. And then lastly, remember, if we raise a number, raise an exponent to another exponent, we multiply. An integer times a fraction, you just multiply the tops. So we wind up with x to the -12 over 8. Okay. Now I'm going to simplify the fraction first because it's going to bother me if I do it, if I wait to do it till the end. And then I'll move it down to the negative, down to the denominator. So 12/8 is divisible by 4 on top and bottom. So this becomes what? -3/2. And then the negative, I'm just going to make the negative positive. So I'm just going to bring it down. So -3/2 or becomes a +3/2 in the exponent when you put it in the denominator. Yeah, I'm going to write it a little bit bigger. I need to start writing a little bigger. Yes. Okay. These aren't easy per se, but these are just what made these hard was the fact that it was fractional exponents, right? The hard part of these hopefully should be the adding and subtracting fractions, and then the simplifying the fraction, like the basic algebra stuff. I'm hoping you understand that or remember the exponential notation, right? Multiply them, you add, divide them, you subtract, raise them to another power, you multiply, right? Hopefully that's the easy part. And really, in a weird way, I'm hoping the hard part's the more basic algebra. Any questions before we go on? Because I think now we're going to simplify. Yeah, we're going to do, this book kind of builds on itself with this section. Okay, so what time we have? Oh, yeah, holy cow. It's only 30 minutes in. Time's not flying. I wonder if that means something. Let's look at number, I'm going to just steal some from the homework. Let's look at number 18. It's a practice problem, but I wonder if there's one like that in the back. Usually one in the homework. Kind of. Yeah, let's look at number 50 in the homework. So number 50 is on page 524. Okay. And it says parentheses 32 to the 1/5 x to the 2/3. That's a 3, 2/3. And then we're raising that to the third power. Okay. Kind of show you how I would tackle this one. Now we've got a few things going on here. So it's 32 to the 1/5, x to the 2/3, and then we're raising that entire thing to the third power. I'm going to see if I can simplify anything in this parentheses first before I get going, because then I'll bring the 3 in to make stuff bigger. And I'm kind of noticing this 30. Now, x to the 2/3 I can't do anything with. And we're not dealing with radicals. This is just simplifying, okay? Use the properties of exponents to simplify is what it says. So we're not worried about moving anything over into radical form or anything like that. But 32 to the 1/5 I can simplify. Now look, if you've got your calculator in front of you, do you have it in front of you? Okay, here's how you would put this in your calculator. Yeah, and you can, if you want scientific, if you got a smartphone, like look, like my smartphone. Hold on. If you got a smartphone, boom. If you tilt that baby to the side, it'll make it a scientific calculator, which is kind of nice. So like for this now, and this would be the same buttons I would press if you that calculator asks you to buy, which is really a better calculator than the phone one, okay? But this is how I would put this into that 32 to the 1/5, how I'd put it into the calculator. You'd actually put it in, I'll write it down here, as 32, the caret button, or there's an X to the Y button on some of them. Let me zoom in. Some old school zooming in right here, right? I don't know if it'll focus. Yeah. See that X to the Y button? That raises it to the power, but also I know in the calculator I asked you to buy, there's a caret button, and that means an exponent as well. okay? And now if I want to put in 1/5 in the exponent, I have to be careful because I have to put parentheses, 1 divided by 5, okay? So for me, for this calculator, I'm going to do 32, and then I'm going to hit x to the y, and notice it makes the caret symbol, right? And then 1 divided by 5, close that parentheses, wherever that is. Oh yeah, right there, okay? Then I'm hit equals, it's probably going to be 2, okay? So 32 to the 1/5 just winds up being 2. But that's how you would put a fractional exponent in your calculator, okay? My beat up phone. I'm really hard on phones. I dislike them, so they wind up getting all beat up. Okay, so I haven't found a phone I like yet. I should put it that way. Like, I'm the worst complainer when it comes to technology. So let's rewrite this now. So this 32 to the 1/5 is just 2. We found that from the calculator. X to the 2/3 raised to the 3rd power. Now I'm going to remember the rule says if you've got parentheses raised to an exponent, you've got to distribute the 3 to both exponents. Now be careful, don't say it's 3 times 2. Remember, you're multiplying by that exponent of 1. So this winds up being 2/3. And then 3 times 2/3. Now remember, integer fraction, you just multiply the tops. So x to the 6/3. Okay. And then 2/3, that's, or 2 to the 3rd, I should say, not 2/3, but 2 to the 3rd. 2 times 2 times 2, that's 8. And then x to the 6/3, well, 6 divided by 3 is 2. So we wind up with x squared, kind of neat. Okay. All that craziness was just x squared, just hidden in there. Okay. Just a really hard way to write x squared. Okay. Any questions? I feel like my lighting is off now. There we go. Oh, that's better. More calm. Any questions about that one? I'm gonna steal another one, and I want you to try it. This is gonna have more stuff going on. Okay, it's 56. 56, and it says in the numerator we have 2x to the 1/5, and then we're raising that to the 4th power. Remember, raising the entire thing to the 4th power over x to the 3/10. Okay. And it's on page 524 if you've got the book open. It's on page 524. But try that one. I'm going to give you a little bit to try it. Oh, sorry. You got it? It's tough, man. There's a lot of stuff going on. Okay, so let's see here. Which marker to choose? Let's do black. First off, I can't. There's nothing to simplify in this parentheses, right? So I'm going to distribute the 4, and I wind up with 2 to the 4th x. Now remember, integer fraction, just multiply the top. So this winds up being 4/5 over x to the 3/10, right? Now I've got to simplify this. So 2 to the 4th I can do. 2 to the 4th is just 16. But look, I've got to subtract these fractions, right? 4/5 minus 3/10. I'm going to do that down here. Minus 3/10. Now, I just need to multiply the 5 times 2 to get the 10. So it winds up being 8/10 minus 3/10. That's 5/10, right? So this winds up being, when you subtract the 4/10 minus the 3/10, that's what we did here, okay? So it winds up being 5/10. So 2 to the 4th is 16. And then we wind up with x to the 5/10. Now 5/10 though is just 1/2. So we get 16 x to the 1/2. Now in this question, it did say to leave it as an exponent. Yeah, so write with positive exponents. This was number 56 in the book. And it says, use the properties of exponents to simplify, and then write with positive exponents. Boom, shakalaka. Okay? Questions? Great. Now the last concept is probably the hardest. And it's simplifying going by using exponential term. So if we had something, and now, so the question will say, use rational exponents to simplify. Assume that all variables represent positive real numbers, okay? So if we had something like the 8th root of x to the 4th. So now we're given a radical, and it says use rational exponents to simplify. So what we're going to do is we're actually going to move this into an exponent, then simplify it, and then put it back into a radical, okay? So if I wanted to write this as an exponent, we've got to go the other way, from earlier. So if I want to write this as an exponent, remember, this is the denominator. This is going to be the numerator. So we wind up with x raised to the 4/8, right? So the 8th root of x to the 4th just winds up being x to the 4/8. And we know x to the 4/8 is just 1/2, right? Because 4 over 8 is just 1/2. And then we're going to write this now back into radical form, okay? Well, 2 is the root now, so it's a square root, and it's x to the 1st power, right? We're done, okay? We're done. These aren't as tricky with variables. They're going to get real weird with numbers. We'll get there in a minute. Okay, let's look at one with more than one variable going on. Let's say we had the 6th root of x squared y to the 4th, okay? The 6th root of x squared y to the 4th. Now, again, I'm going to do the same thing. I'm going to use exponentials to simplify this. So this equals x squared y to the 4th, right? Raised now to the 1/6 power. Okay? Then I'm going to distribute this to both of my exponents. Remember, integer times a fraction, just multiply the top. So this winds up being x to the 2/6 times y to the 4/6. Okay? Questions? Making sense? Now let's simplify each one of these fractions here. So if we simplify the fractions, 2/6 becomes 1/3, right? Because you can divide 2 on top and bottom. 4/6 becomes 1/3, or actually 2/3. Not 1/3, but 2/3, right? Because you can divide 2 on top and bottom. And now here's the crazy part to think about. We can kind of extract the 1/3, where we multiplied the 1/6 then, and we see how the denominators were both 1/6. Well, now we can extract the 1/3 from both of these. So this winds up being x to the 1st power times y squared raised to the 1/3. Whew, this is testing the knowledge, okay? Now think about this. If we checked it, we could get to here. 1/3 times 1 is 1/3, right? 1/3 times 2 is 2/3. So it works out. And then we can write it back into an radical. So this would be x y squared. So hold on, I'm going to kind of separate these a, b, and c down here. Okay. Now this next one I think is this next one will be like the challenge question on a test. Okay, hands down. So we're going to use rational exponents to simplify. Assume that all variables represent positive real numbers. So we've got the sixth root of 25. I'm stealing this straight from the examples in your book. The sixth root of 25. Okay. So first off, let's write this as an exponent. So this would be just 25 raised to the 1/6. Now, with this one, with the numbers, we need to see if we can write what's inside the parentheses raised to a power. If we can write it as an exponential term, right? And it is. We can square something and get 25. So that's 5 squared raised to the 1/6. So that's kind of the cue. Now from here on out, it's not that bad. It's this step that's kind of tough sometimes when you're trying to think of, well, how could I create that number into an exponential term, right? How could I create 25? Like another one's going to be 9, 9, 3 squared, that kind of stuff. But now we can simplify this one the same way we've been doing before. Distribute it through. You wind up with 5 to the 2/6, right? 2 times 1/6, which just equals 5 to the 1/3 when we simplify, right? 2/6. Divide 2 on top and bottom. And then that just becomes the cube root of 5. And I know what you're thinking. You're thinking, that doesn't look any simpler. And I totally agree with you. It's not really any simpler. These are just kind of challenge questions to make sure you understand the concept. They might show up on the test, probably not. Okay. But they really kind of test your ability when it comes to going back and forth from the radical form to the exponent, and then simplifying it in a way with exponentials that we can just kick it back into the radical form. Okay. I'm not as worried about this as you learning it per se as the stuff at the beginning about going just back and forth from radical and exponential and simplifying. Okay. So don't get too, if you're doing the homework and you're like, oh my God, I do not get this, don't sweat this part, okay, as much. I want you to learn the base first before we can get rocking and rolling. Okay. Man, we've done it all, I feel like. Well, there's a few more. Rational expressions to write as a single radical. Okay, this one actually I think is a little easier. Yeah. So I think this one's easier than the last one to really grasp. So let's say we have two separate roots. Now we know, remember the root, what am I trying to say? The multiplying radicals rule said you had to have the same root to multiply radicals. And you wound up with a times b, the nth root of a times b, right? Well, if we're given separate roots, we can still combine these, but we have to use exponents to do that. So if I had like, let's say the square root of y times the 6th root of y, okay? I can't use this rule that we talked about yesterday because both these radicals have different roots, so I can't just combine them underneath. Instead, I can make these into exponents and then do the same thing, okay? So check this out. So if I want to make this into an exponent, now remember there's a square right here. We just don't write it. So it's y to the 1/2 times y to the 1/6. Now it turns into that example that we talked about a few pages ago, right? You know, y to the 1/2 times y to the 1/6. Okay, I got to add 1/2 and 1/6 together. I'm going to do it up here. 1/2 plus 1/6. 6 stays the same. I just need to multiply 3 on top and bottom. So I wind up with 3/6 plus 1/6, right? So this becomes 4/6. So 1/2 becomes 3/6. Add the tops, you get the 4, keep the 6. So this winds up being y to the 4/6 power, which we know y to the 4/6 is actually y to the, what, 2/3? Okay, so now full circle, I'm gonna come down here. I'm gonna write this as a radical. Now I'm gonna put the squared under the root. So it's gonna be the cube root of y squared. So this turns into the cube root of y squared. Now this is something we could use, right? When we get to solving, and let's say we had to combine these two to solve it, we have a way to combine it using radicals to do that, okay? We have a way to combine it using radicals to do that. So let's look at one that's I want you to try this one, it's just a fraction. So I'm going to steal it from the book again. Let's say the cube root of x divided by the 4th root of x. So I want you to try that one. So put it into rational form or exponent form and then simplify completely. So put it into exponent form and then simplify that thing completely. That easy? Easy peasy. Okay, let's see. Okay, hold on. The cube root, again, we're going to write that as 1/3, right? We're going to write this as 1/4. So now we've got to subtract 1/3 minus 1/4. I'll do that over here. So 1/3, didn't we do this already? Well, we did. So we had to multiply by 4 here, by 3 here. So we wind up with, oh, I gotta cut myself off here. 4/12, I should say, minus 3/12. So we wind up with 1/12. So this winds up being x to the 1/12. 1/3 minus 1/4 is 1/12. Well, we know how to write 1/12 as a root now. This is just the 12th root of x. It's kind of crazy to write. I don't think we've seen a 12th root so far, but that's what it is. Okay. Any questions before I go on to a few? I'll just do one more example with numbers. Numbers look weird, but they're not any different. Okay, we're not going to treat them any different anyway. Okay, so let's look at one with numbers. Let's say we had the square root of 5 times the cube root of 2. Oh, lost my mask. Square root of 5 times the cube root of 2. Okay. The first thing, again, I'm going to write this as an exponent. So it's 5 to the 1/2 times 2 to the 1/3, right? Now, this one is different. Ooh, this one is not going to be easy. Okay. Now look, what's different, let me go back to this last page here. What's different about these is every example we've done so far had the same base. So we could combine them. Once we got to this point, I subtracted. Once I got to here, I can add these together because I have the same base y and because I have the same base x. Over here, I don't have that. I've got a base 5 and a base 2. It wouldn't matter if I got common denominators per se. What am I trying to say? I'm sorry, guys. I couldn't add these tops together because I don't have the same bases. That's what I'm saying. I couldn't add the exponents because I don't have the same bases being multiplied. But what we could do, we could get the same denominator. And if they had the same denominator, that means they could be under the same root. Okay? So what I'm saying is like, look, this 1/2 and 1/3, the least common denominator for 1/2 and 1/3 would be 6, right? So I would write 1/2. If I want a denominator of 6, 1/2 would be 3/6, right? Times, now 1/3, if I wanted that with the denominator of 6, that would be 2/6. Follow along with me. So and I'll show you why exactly I got the same denominator. So I've got the same denominator here. Now, remember how we factored out the denominator in one of those previous examples? So if I factor out the denominator, now look, 1/6 times 3, that's the 3/6. 1/6 times 2, that's the 2/6. So I factored out the 1/6. And then I can write this as the 6th root of 5 cubed times 2 squared. And just because I am curious as all could get out, I'm going to find whatever this number is. So I'm going to take my calculator. I'm going to say 5 times 5 times 5 times 4, right? So 500. So I get the 6th root of 500. That one's tough. I'm going to tell you right now. I'm not going to put that on test. But just because I like challenges when it comes to math, of course, probably why I teach math, I would probably try this one at the end to challenge my skill set. See if I really grasp it. That's a tough one. Okay, that's a tough thinker right there. Now, I'm also going to see if this 500 simplifies. I need to see if for some reason it has a 6th root hiding in there. This is 5 times 100. That's prime. 100 is, you know what? I'm going to stay with the 5s. It's 5 times 20, right? 20 is 5 times 4. Oh, we know what it breaks down to. What am I thinking? This is 2 times 2. We don't have a 6 of a kind at all, right? 3 5s, 2 2s. So this would stay as the 6th root of 500. Okay? Any questions, comments, or concerns? Let's dig the homework up. So for homework, I want you to really focus on the first part. So on page 524, really focus on 1 through 39 odd. That's going to be the main part of this homework. The rest, though, are just kind of challenging questions, okay? 41 through 85. Challenge. If you don't have much time, I would just do 1 through 39 odd. And then if you want to check and see where you're at, kind of your barometer of understanding or not, 41 through 85 will really tell you if you really understand radicals and exponentials. Okay? Do you guys have any questions on the Zoom session? Any questions moving forward? Okay.